Hi there. I'm glad you're here. Set the day down beside you. Let your shoulders soften and feel your breath settle like a quiet tide. The room is dim, the blankets are warm, and the night is on your side. Tonight we'll drift to the far edge of what we think we know. Astronomers, peering with the James Webb Space Telescope, have noticed glimmers so ancient they nudge the boundaries of our origin story light that seems to whisper, the beginning might be stranger than we imagined. Not a proclamation, but a gentle puzzle, inviting us to listen as the universe clears its throat. You won't need equations. I'll carry the details while you rest, following those faint signals through a calm, unhurried story. If this soft journey helps you unwind, a quiet like and subscribe helps others find their way to it too. No rush, no fuss. For now, ease a little deeper into comfort. Breathe. Let curiosity rock you towards sleep. For a long time, the picture we carried of home was smaller than the night itself. The old diagrams showed a neat spiral, measured like a dinner plate, 100,000 light-years across, tidy, contained. Yet when new instruments looked more carefully, the edges softened and slipped outward, as if the light had been breathing just beyond the frame all along. Our galaxy is roomier than the maps in our heads, a house with extra halls discovered late after everyone had already gone to sleep. Trying to measure the Milky Way from inside, it is like standing in the hush of a city at midnight and guessing where the city ends by listening for the last echo. We're tucked into one arm, about 26,000 light-years. From the center, lanterned in starlight and dust. Buildings crowd the view, street lamps blur into mist. You trace the skyline as far as your eyes will let you, and where the light's thin, you think, there, surely that's the edge. But the city keeps going in quiet neighborhoods you can't see from where you stand. Galaxies don't end like plates. They fade like shorelines at dusk. Bright stars give way to sparse ones, then to streams and wisps, then to the wide, dark scaffold that doesn't shine at all. For years, we counted the obvious light and called it the whole. What we missed was the delicate halo, a veil of faint stars, cold gas, and the hidden mass that wraps everything in a gravitational hush. The clues arrived as scattered whispers. Stars at the outskirts, moving faster than they should. Small companion galaxies looping far beyond the tidy boundary. Calculations that wouldn't balance, like a scale that insists there's more on the plate than your eyes can see. Then the quiet became a chorus. A spacecraft named Gaia began taking the galaxy's pulse, measuring the motions of more than 1 billion stars with a watchmaker's patience. Radio dishes listened for hydrogen, the most common atom tracing its faint breath farther from the bright disk than we expected. Infrared eyes slipped past the soot and fog of dust, finding what ordinary light could not. Even Webb, peering deep with a steady gaze, helped refine the distances to standard candles and the character of far-flung clusters, nudging our map to make room where we had drawn the line too soon. Another key arrived in the form of rivers' stellar streams, long and graceful. Made of stars pulled from smaller galaxies, the Milky Way once folded into itself. These streams are fossils, but still remember the path of the tug that shaped them. Follow their arcs, and you can feel the galaxy's pull, not just where it is bright, but where it is simply heavy. Their orbits wander well beyond the old edge, circling in a space we once thought was outside. The picture redraws itself, the Milky Way reaching farther, the halo stretching wider, the night around us thicker with quiet mass. When you listen to the motion instead of the glow, a deeper pattern emerges. Everything orbits the center stars, gas, globular clusters, little galaxies that tag along like fireflies, each moving at a speed set by the gravity that holds them. Near the rim, those speeds stay stubbornly high. If the visible matter were all there was, the stars would drift away like leaves on a river. They don't. Something unseen keeps its hand on the small of their back. We call it dark matter, not because it is sinister, but because it doesn't shine. Think of it as an invisible framework, a soft cocoon of gravity, carrying the weight that light refuses to show. From a distance, other galaxies are easier to weigh. Andromeda sits 2.5 million light-years away, and distance grants perspective. You can see it whole face, profile, and edges at once. With our own galaxy, we're too close to step back. It's like trying to take a portrait of your face while standing inside a fog bank. So we build the picture from touch. A pulse here, a drift there, a thread of stars curling through the dark. Every new instrument adds another fingertip to the map. What does it mean, this larger home? Timelines shift a little, like a clock adjusted to keep better time. The future dance with Andromeda is still written, but the steps and spacing are tuned by a truer sense of mass. The hunt for life widens too. The space we search is not just deeper, it is more generous. There are more quiet neighborhoods where stars and their planets might circle in the long calm of the outer disk. More places for warm oceans to dream under unfamiliar skies. Numbers in textbooks change, yes, but what they carry into your evening is simpler. Wonder and a gentle reminder to keep some room in your certainty for surprises. And if we could be so mistaken about our own address, it doesn't scold us, it invites humility. The universe seems to like teaching with soft erasers, letting us redraw the outline again and again until the shape fits the light a little better. So we lie back, listen to the hush between heartbeats, and picture our spirals stretching beyond the familiar drawing. A lanterned city at night with more streets than we knew. The edge isn't a wall, it's a fading shore, and beyond it, the dark holds us kindly, steady, and wide. Breathe in, as if the galaxy breathes with you. Breathe out, and let the larger map unfold. On that larger map, a quiet flock of companions drifts around our spiral. The large Magellanic Cloud, the small Magellanic Cloud, the Sagittarius Dwarf, little lanterns moving to the music of our galaxy's full weight. The seen and the unseen together follow their paths, and you can feel that music take shape. Each loop and tilt a fingertip pressed into soft clay, gravity's imprint left behind. Gather those trails, and a clearer portrait emerges. Our home isn't the modest spiral we memorized in school. It carries itself like a heavy weight, twice the width, roughly 3 times the mass shoulders, broader than the charts ever allowed. Measuring from inside has always been a tender difficulty. So the sky offered another clue. Streams of stars, long and pale as spilled milk under moonlight. They sound exotic, but they're simply evidence that time keeps records. Long ago, small galaxies wandered too near. Our gravity reached out, tugged, and unspooled them into ribbons. The stars didn't vanish. They stretched into rivers that circle us still, like handwriting that refuses to fade. Some streams are wider than Earth's entire path around the Sunday. Others move like a school of fish, thousands of stars keeping formation as if breathing together. For years they sat at the edge of the picture, dismissed as background murmur. Then, the room grew quiet enough to hear them. These rivers became rulers, gentle and exact, laying their length against the galaxy to show what brightness alone cannot. A stream obeys gravity the way a feather obeys the air. Every turn it takes is set by the mass that holds it. Trace the curve and you're tracing the invisible hand. No guesses, no arguments, just motion answering to pull. The Sagittarius stream became a kind of ribbon around a gift, wrapping the Milky Way multiple times, reminding us that the bow we once drew was too small. Far outside the old boundary, the ribbon kept circling, and so too did our gravity. Then came GD1, a slender river threading the outer halo. Its path bent in ways that didn't fit the tally of shining matter. Either the rules had cracked, or something heavy was hiding in the dark. The choice that remained was the one the night has been offering for decades: dark matter. Always the quiet weight. When you hold these streams up to that invisible ink, the letters brighten. The shaping pull doesn't end where the stars turn faint. It continues, twice as far as the glow suggests. Stranger still, a few streams roam where we once labeled the map between. Intergalactic, we said, as if the space beyond belonged to no one. Yet those rivers curve to our gravity all the same. The orphan stream haunted the edge of certainty for years. Was it ours, or claimed by a neighbor? New measurements settled the question. It belongs to this home, which means the home extends that far and farther still. With each discovery, the radius grew by quiet steps 5,000 light-years, then 10, then more until the numbers gathered into a new horizon. 120,000 light-years, 150,000, 180,000. The streams did not argue. They simply kept pointing outward. Around 200,000 light-years, the pattern held, like a shoreline revealed by receding fog. The surprise wasn't the size anymore. The surprise was how long we'd been content with a smaller room. What we see with our eyes is only the lit skeleton, the bones, the windows, the bright lace. Much of the structure is night itself. Dark matter stopped being a suggestion and became a map, charted by the way stars move too fast to be held by light alone, by the way galaxies spin without flinging their edges to the wind, by the way distant beams bend around something that refuses to shine. In our own spiral, the unseen doesn't just add a little heft, it is the frame. Picture a skyscraper in darkness, where only the windows glow. The steel that makes the shape is there, strong and patient. You simply can't see it. The ratio of that hidden mass to the glowing kind runs roughly 10 to 110 measures of quiet weight for every measure of star you can count. This unseen frame swells into a halo that is more cloud than shell, spherical, diffuse, stretching far beyond the bright pinwheel we paint on posters. Older measurements stopped where the sprinkling of stars thinned to almost nothing, but the halo doesn't notice our preferences. It goes on. Think of an iceberg drifting under a pale sun. The tip is beautiful, detailed, easy to love. Beneath the surface lies the mountain. Even the bending of faraway light helps sketch the mountain's size. When a distant galaxy's beam passes near ours, the dark matter tilts it by a whisper. Measure the tilt, weigh the hand that made it. Follow that logic to the quiet outskirts, and you find the halo reaching toward 400,000 light-years when the faintest regions are counted. The night has a soft border, and softness is hard to define. Where does a galaxy end and the honest emptiness begin? There is no bright fence, only a slow fade. For a practical line in the dark, astronomers use a kind of threshold, the place where the Milky Way's hold still gathers things into a family. Inside that embrace, stars, gas, and companions move together. Beyond it, they drift free. Set that boundary, the virial radius, near 200 to 250,000 light-years, and the old number folds back like a corner of paper, replaced by a truer edge. All because of invisible mass. The idea rearranges the furniture in our heads. Galaxies aren't islands of stars, floating alone on a black sea. They're immense halos with a luminous core, a lantern glowing within a larger, quiet sphere. The brightness is decoration, the unseen is structure. And if our spiral wears such a cloak, so do the others. The universe, measured by the hush rather than the glitter, is heavier than our first lullabies ever admitted. Lay back into that thought, the way you might sink into a warm blanket. Picture the Milky Way as a city at night, seen from above boulevards of starlight, threading a wide, dark park. Beyond the last bright avenue, the park keeps going. Paths curve, trees sway, and the air still belongs to home. Breathe with it. The edge you learned as a child wasn't a wall. It was a dim shoreline. The tide always out a little farther than we knew, drawing your gaze to where the dark begins to glow. Along that shoreline, other lights gather a small company of companions, like quiet moons to a larger world. From southern skies, the largest reveals itself, the large Magellanic Cloud, a soft smudge holding roughly 30 billion stars. Nearby, the small Magellanic Cloud carries several billion more. Farther out drift the dwarfs Sagittarius, Draco, Ursa Minor, each a pocket of history, each a curl of starlight, each tracing a long, patient orbit through the dark. For a while, we treated them as passers-by, a procession of neighbors slipping past our front door. Then the measurements settled, patient and clear. They are not drifting through, they are held. Bound within our galaxy's quiet grip, they move to a rhythm set by the Milky Way's true weight. Time their steps, and you weigh the dancer. A companion like the large Magellanic Cloud sits about 160,000 light-years away and takes roughly 1.5 billion years to complete a great loop. To keep that pace at that distance, our home must be heavier than the tidy estimates once penciled into textbooks. One by one, the satellites told the same story. Orbits farther out than we expected. Speeds a shade too quick for the old mass. The conclusion glowed like a street lamp in fog. The Milky Way is bigger, and it leans on the night with more gravity than we guessed. Then the sky offered a softer, stranger testimony. Tidal streams. When a small galaxy wanders too near, our gravity teases it apart, not in an explosion, but in a slow unspooling. Stars are lifted and laid into long scarves of light that wrap around us like pale ribbons. The Sagittarius dwarf is being undone this way right now. Its stars trace a luminous path across the whole sky. These tales make honest rulers. Where the stream is pulled tight, the field is strong. Where it relaxes, the pull has thinned. Follow enough rivers and the shoreline of the galaxy appears not as a hard edge, but as a fading reach. Some streams run beyond 150,000 light-years. Some touch 200,000. A few hint even farther. The satellites weren't bragging. They were simply telling the truth. Our home is vast. Maps ripple when truth like this arrives. If the Milky Way's embrace stretches wider, then the local group, our little cluster with Andromeda and friends, needs redrawing. The space between big neighbors shrinks a bit. Their influence reaches longer. The slow waltz of approach and merger begins earlier than we penciled in. Each satellite becomes a data point, each orbit a careful stroke on a larger canvas, and together they sketch a giant where we once pictured something modest. Out at the dim edges, new companions still appear shy dwarfs hiding in the grain of the data. Every few years, another one steps into view, and the boundary drifts outward like tidewater reaching one pebble farther up the shore. How many wait in the half-light? How wide does this home become when all the faint pieces are counted? Numbers this large slip through the fingers. 200,000 light years is a phrase the mouth can say, but the mind can't hold. Convert it to miles, and it only grows more slippery. About 1.2 billion trillion, a pile of distance that refuses to sit still. Think instead of time. Even at the universe's speed limit, a beam of light would need 200,000 years to cross our disk. By the time a signal leaves one edge and touches the other, entire chapters of human story would have opened and closed, continents of memory grown and weathered away. Or lean on scale. If Earth were a grain of sand cupped in your palm, the Milky Way would stretch far beyond the path from Earth to Saturn, farther than that. Really, farther than the comfort of backyard comparisons. Or, consider the light from the far rim. It set out before modern humans had found their stride, before Neanderthals, before even the walkers we call Homo erectus. It has been traveling since our ancestors were closer to trees than to telescopes. Of course, the heart balks. We were built to make sense of paths we can walk in an afternoon, not to cradle galaxies. And yet the immensity comes close, as intimate as breath. A galaxy twice as wide doesn't just add space, it swells in volume like a lung, growing not by 2 but by 8 when the radius doubles. 8 times the room for stars to burn quietly, for planets to circle, for moons to tug at hidden seas beneath ice. 200 billion stars become something nearer 400 billion, and every one of them is a little hearth with the possibility of company. Somewhere there may be warm rain under a different sky, a tide responding to a small, cold moon, a night breeze stirring leaves we've never named. Let that settle the way darkness settles in a room after the lamp is turned low. Our address is larger than the picture we learned, and that largeness is not distant from you. It surrounds you, holds you, gives you more sky to dream in. Breathe with it slow in, softer out, and feel the edges of home drift outward, gentle as a tide, until the vastness itself feels like a blanket pulled up to the chin, and in that calm, the mind finds space to wonder what else might be awake beneath the same night. Beneath that blanket, a quiet thought arrives. If life is uncommon, say one spark in a billion star systems, the widened map stops being abstract and starts feeling personal. It's the night, quietly doubling the number of lanterns. It might light 200 billion extra chances tucked into the dark, like seeds after rain. If minds have bloomed somewhere out there, the odds of our paths crossing lean a little closer, not with fanfare, but with a patient nod. Scale doesn't only touch curiosity, it reaches into our calendar. Across the quiet, Andromeda glides toward us at roughly 70 miles each second, a slow, steady tide on a beach so wide we can't see both shores at once. Galaxies don't collide like cars. They pass through, their stars separated by so much emptiness that direct impacts are rare beyond imagining. What changes is the choreography, the gravity, the swell and sway, the long reshaping of orbits and clouds. For years, the first steps of that meeting were placed about 4.5 billion years ahead. A heavier Milky Way stretches its influence farther, like a breeze that reaches leaves you didn't think it could touch. That means the dance begins earlier, perhaps in 4 billion years, perhaps a little less. If our line continues through that future, your distant descendants could watch Andromeda loom night after night, growing wide and bright, until it paints half the sky with its soft, grainy light. The early movements happen where eyes can't see. Each galaxy wears a hush of dark matter around it, a halo hundreds of thousands of light years across. Those halos meet first two invisible auras brushing. When they mingle, the pull changes. Stars feel two centers at once. Some are tossed outward like sparks, some shepherded inward, and the great disks begin to drift through each other like slow, overlapping clouds. Direct star-on-star collisions remain vanishingly rare. You could slide millions of Earths between neighboring stars, but the gas they carry compresses, and the night blooms with new stars kindled in the wake of the turmoil. There will be passes and returns, spirals intertwining, each encounter tugging strands loose. Tidal forces pull at the arms, sculpting long, luminous ribbons that stream away into the dark. The neat pinwheels become warped and wind-tossed, their original shapes hard to recognize. After perhaps 1 billion years of this slow waltz, the two relax into one no longer a spiral, but a massive elliptical, the starlight moving in many directions at once like a city's traffic seen from very high above. Astronomers have a playful name for that future home, Nilkamida, a gentle nickname for the end of two old spirals and the beginning of something larger. And what of us? The sun sits far from the busy center. It will probably drift through the encounter without a direct shock. Earth could find its orbit nudged, perhaps even flung outward into a lonelier path, or it may simply circle on, a little altered, a little readdressed. The odds favor survival of the system, at least for a while. Yet the sun's own clock is shorter than the galaxy's. With about 5 billion years of fuel left, our star will be nearing its last steady chapters as the first act of the merger unfolds. We may be here for the opening. Then the curtain will descend on the light that warmed our oceans. There's a further whisper at the edge of certainty. If our estimate of the Milky Way grew, Andromeda's might too. Two larger halos mean an earlier touch, a firmer pull, a final galaxy even more massive than the sketches suggest. Some signs hint the auras already overlap, that the first threads of interaction are underway now. Slow, invisible, tucked into the dark matter that neither eye nor camera can catch, only gravity. On human scales, 4 billion years is forever. On the universe's scales, it's tomorrow, and tomorrow has drifted a little nearer to the window. All of this rests on weight. The night keeps asking us to count mass rather than glow. For years, we carried a figure for the Milky Way, around 1.5 trillion times the sun's mass, most of it hidden. New lines of evidence have thickened that number to something like 4 trillion, perhaps more. It sounds like fantasy until you remember what one's solar mass is. The weight of our sun, so vast that the rest of the solar system together barely totals 1/100th of it. Now imagine stacking those suns not by the hundreds or millions, but by the trillions, and you begin to feel the hush that holds our spiral in place. The added heft didn't arrive. It was always there, waiting for us to measure it with steadier hands. Earlier estimates leaned on what glows stars and gas, and on rotation curves near the bright disk. The outskirts, where the dark matter dominates and the starlight thins, remained a blur. Then the tools got quieter and truer. Satellite galaxies became clocks at great distances. Stellar streams traced the curvature of the field like silk on wind. Simulations offered thousands of test galaxies with known masses, letting us match our home to its closest cousins. Different methods, same answer, a heavyweight. A galaxy with deeper gravity holds its retinue more tightly. It can gather more small companions, tug stars from passers-by, and set a stronger tempo across the local group. We used to think Andromeda was the certain elder sibling. The new measurements suggest a tie, or even a slight edge for us. Two superpowers moving toward a shared horizon, each on the order of 4 trillion solar masses. each wearing a halo that reaches far beyond its bright heart. Weight also tells a story about how we grew. Large galaxies are built from many meals. Streams in the halo are the letters of that history, the remnants of dwarfs we folded in. The Sagittarius dwarf is mid-sentence now, being pulled apart, its stars smeared softly across the disk. Give it a few 100 million years, and what remains will be faint ghosts in the data, fingerprints more than faces. This is the slow metabolism of the universe, not cruelty, just the patient recycling of light. Hold one last thought before sleep takes the reins. If our galaxy truly weighs in at trillions of suns, and most of that mass is quiet and unseen, then we live in a structure whose substance is largely invisible. The windows glow, the frame is dark, yet the frame is what keeps the house standing, what steadies the night around us, what lets streams curve and satellites stay, what draws Andromeda near on that long, inevitable tide. Breathe with that knowledge the way you'd breathe with the ocean, slow in, slower out, and let the scale of it turn gentle in your chest. The future is vast, the present is tender, and the dark that holds us is not empty at all. Here is the part we rarely see. Most of what holds us slips past our eyes and hands. 9 parts in 10, like a silent ocean we cross without feeling the water. Home is 4 trillion suns worth of weight, and most of it does not shine. The Milky Way doesn't stop where the bright lace of stars thins. It keeps going, and going, into a realm shaped almost entirely by gravity's hush. Astronomers give this hush a name: the dark matter halo, a vast, nearly spherical cloud of invisible particles surrounding the glowing disk like night air around a lantern. It isn't an ornament, it is the structure. Close to the center, it's dense, and then it fades softly outward. A practical boundary, the place where everything still moves together under our galaxy's pull, sits near 250,000 light-years. That's the virial radius, a kind of gravitational shoreline. But some maps, drawn from models and hints, suggest the halo might breathe farther. 400,000 light-years, 600,000, perhaps even 1,000,000. Imagine that reach. Andromeda rests about 2.5 million light-years away. If both halos spill out 1,000,000 light-years, the gap of truly empty space between them shrinks to a mere 500,000. 2 invisible clouds already brushing sleeves in the dark. We do not see the halo directly. Dark matter doesn't glow, doesn't absorb, doesn't speak in light at all. It speaks only in the curve of things. So we listen to orbits of the small companion galaxies. We watch how distant beams bend gravitational lensing, space itself tilted by mass. We compare to careful simulations of galaxies grown in silico. All paths point to the same shape, a great halo, no sharp fence, only a long, gentle fade into the in-between. The halo answers old puzzles. Stars far from the center spin too quickly to be held by starlight alone. The halo steadies them. Whole galaxies rotate without their edges flying apart. The halo is the extra hand. Extra lensing shows up where there's no glow. The halo is the reason the light bends. Stranger still, you are inside this structure. Dark matter drifts through the room you're in, through your body, through the Earth itself, trillions of soft, non-speaking particles passing by each second, like mist no skin can sense. Deep underground, instruments wait in the quiet for a single particle to nudge an atom. The waiting continues. Either the particles are rarer than we thought, quieter than we imagined, or we have not yet learned the right way to listen. If the halo truly reaches 1,000,000 light-years, then our gravitational address is enormous, Much of the local group sits within our long embrace. Galaxies become seeds settled in the flesh of their halos, not isolated islands, but orchards of gravity, where the fruit is light and the branches are unseen. What we see is garnish. What holds it is scaffold. Spin tells the tale in another light. In a family like ours, the solar system, the farther you go from the sun, the slower the path. Mercury sprints, Neptune strolls. By that logic, stars in a galaxy should slow with distance from the center. Yet when you trace their speeds across the Milky Way, the curve doesn't fall. It stays almost flat. Outer stars move nearly as fast as inner ones. That would be impossible without more mass than meets the eye. The flat rotation curve is the smoking ember, the steady sign that the halo is real. Even so, the details keep us awake at the edges. Some stars out near the rim travel at 130 to 150 miles per second, skimming just under the speed that would let them drift away forever. It's as if they're forever on the lip of leaving, yet remain held by a whisper. Perhaps our galaxy weighs even more than we've counted. Perhaps the halo's outer layers are denser than we guessed. Or perhaps our home recently grew folding in a sizable dwarf that sent a spray of stars into fast, restless paths. Mergers do that. They load stars with extra energy that takes eons to damp and settle. The Sagittarius dwarf, being unwound right now, is delivering just such a scatter. Give those stars 1 billion years and they'll look like native halo wanderers, fast, faint, barely bound. There are puzzles on the other side as well. Lonely slowpokes, stars that dawdle where speed would be expected, as if moving through honey. The rotation story should have been simple: measure, weigh, agree, and instead, the data blooms with quirks and corners. That's where theories of dark matter are put to trial. Warm dark matter would smooth the structure. Cold dark matter, our current favorite, makes lumpier, clump-rich halos. Self-interacting dark matter would soften cores in different ways. Cold fits best so far, but not perfectly. A few small, nagging mismatches remain the kind that could be the first notes of new physics or the last squeaks of calibration. And our larger map only increases the work. A wider halo means more volume, more streams, more stars at odd speeds, more whispers to interpret before sleep. Physics holds steady everywhere else we've looked, from planets curving around suns to star clusters in quiet ballet. Here at home, in the full rotation of our own spiral, there is still a sliver of mystery, a space left open for revision. Let that be a comfort rather than a worry. The night is not empty. It is well built. We rest in a house whose frame is dark and strong, whose windows glitter, whose halls run farther than our first sketches allowed. Breathe with that house. Slow in, slower out. Picture the halo as a gentle sphere that keeps the stars circling, keeps the story together, keeps Andromeda's tide already tugging at our sleeves. Somewhere inside that sphere, on a small world warmed by a middle-aged star, you are listening, and the unseen is holding you just the same. Inside that embrace, the Milky Way wears its beauty in spirals, though even the spirals won't agree how many there are. 4, say the old diagrams, perhaps 5, perhaps 6, murmur newer maps. Imagine great rivers of stars, gas and dust curling outward from the bright heart. Perseus and Sagittarius, Scutum, Centaurus, and Norma, Cygnus threading like a pale stream through a stand of trees at dusk. These are the lively places where stars are born, nurseries glowing through the haze. As our sight grew kinder to the dark infrared eyes slipping past soot and radio ears tracing the breath of hydrogen hidden features stepped forward. A shy arm near the core, the far 3 kiloparsec arm, revealed itself where ordinary light could never look. Closer to home, the familiar lane we travel, the local arm, began to look less like a spur and more like a limb, perhaps stitched to larger structures farther out. And along the rim, where we once saw only scattered lanterns, careful mapping uncovered the outer arm with its own deliberate spiral, a design written where we had penciled emptiness. The strangest part is how these spirals endure. Stars near the center circle quickly. Those farther out move with unhurried steps. If arms were made of the same stars staying in place, they'd wind tighter with every turn, smearing into a featureless disk like cream stirred into coffee. They don't. For billions of years, the pattern holds. The best story we have says the arms are not fixed things, but waves of crowdedness, density waves, regions where stars and gas momentarily bunch up, like cars in a traffic jam that stays while the cars themselves roll through. The math sings well enough, yet the sky keeps improvising. Some arms boast more young stars than the theory expects. Others show gaps where there ought to be company. The outer arm feels too weighty to be just a passing wave, perhaps a scar from an old encounter, a quiet tug that drew material outward long ago. Then came Gaia's patient measurements, 1 billion stars pinned with exquisite care. The spiral pattern, once drawn as clean loops, frayed into something more alive: branches, spurs, breaks, little tributaries lighting up and fading like fireflies. Some astronomers began to whisper that our home might be flocculent rather than grand design. Patchy, textured, arms that grow like the limbs of a tree, reaching wherever sunlight and chance allow. Different instruments, different traces, different answers, all true in their own way, because each is listening to a different voice in the choir. Which brings us to the edge, that elusive line we keep trying to draw in the dark. If a galaxy were a country, we'd expect a border sign. None exists. Stars simply thin, then thin again, until there are only a few wanderers and then none, except sometimes there are a few after that. Where does the Milky Way stop and the in-between begin? The universe doesn't love our neat categories, so we keep practical rules. One line comes from light, the optical radius, where the bright disk fades beyond easy seeing, a comfortable answer near 100,000 light-years. Useful for what glows, but it leaves out the dim and the distant, the old red dwarfs, the faint clusters, the wisps that refuse to shine. It's like measuring a city by counting skyscrapers and ignoring the quiet streets where people actually live. A sturdier line comes from motion, the virial radius, the place where gravity's embrace still keeps things moving together. Roughly 250,000 light-years for our home. Inside, stars and gas are part of the family. Beyond, they begin to drift on their own. Even that boundary blurs. Some stars outside that line still share our motion, born here and loyal in their drift. Do we call them ours? The math shrugs. Common sense nods softly. Then there is the halo that doesn't care where we draw anything. If the dark matter swells out toward 1 million light-years, the word edge becomes a suggestion. It fades like the upper air of Earth's atmosphere, technically present, far beyond where the sky feels like sky. At 100 miles up, the air is almost gone, yet atoms cling thousands of miles out. Where should the line be? The answer depends on what you need to do with it. The problem grows knotty in the winds. Supernovae bloom and blow. Stars exhale, and gas streams outward in great, pale outflows. Some of that breath cools and falls back like evening mist. Some escapes forever, joining the long, thin hush between galaxies. When does that gas stop being ours and become the intergalactic medium? The Magellanic Clouds muddy things further, trailing a river of gas, the Magellanic Stream across the sky. Is that river theirs? Ours? Both? The data makes a map. The names we give it are a matter of use. And from the far side, Andromeda's reach meets ours. Dark halos may already be interlaced. Two auras sharing space like overlapping rings of candlelight. Once they touch, you could argue the dance has begun. If the halos are one long fabric with different bright knots, where does one galaxy end and the other begin? The answer you choose shifts masses, revises sizes, nudges the date when first contact truly counts. In practice, astronomers keep multiple rulers in the drawer. The star-forming disk ebbs where the cold gas gives up. The family of bound companions fades near the virial line. The halo stretches as far as the models and measurements agree to call sensible. None of these is wrong. None is complete. The Milky Way is less an object than a region, a neighborhood with a crowded downtown, a leafy middle distance, and a countryside that slowly thins into open land. 200,000 light-years is the best soft answer we have for the lived-in part tonight. Ask again in a decade, and we may hand you a better softness. Let that uncertainty be cozy rather than cold. Borders are human comforts. The cosmos prefers blends. Our spiral isn't a machine with bolts and edges. It's weather patterns that hold, while everything inside them moves. Somewhere within those patterns, you lie in a quiet room, listening. The arms curl and branch. The edge fades like twilight. The dark halo carries the whole in patient hands. Breathe to its rhythm. Slow in, slower out, and let the map stay generous. What we haven't seen yet is already there, waiting for a kinder light and a steadier gaze. Out where the galaxy thins to a whisper, some stars move like skaters at the very lip of the pond, swift, silent, daring the ice to hold. One sprints at about 130 miles per second, another at 150, a few touch 200. Speeds like that should carry them out into the cold between galaxies. They should be gone. They are not. Something keeps a gentle hand at the small of their backs. Astronomers call these wanderers high-velocity halo stars. They are not the true escape artists, hypervelocity stars that race past the limit and slip away for good. These are the almosts, the just barelys, skating the edge and somehow remaining ours. Finding them meant learning to listen for very faint footsteps. They are distant, dim, scattered across a volume so large it makes language feel small. Then Gaia arrived with its steady heartbeat, measuring positions and motions for millions upon millions of stars. With the care of a watchmaker, plot the sky, track the drift, solve for speed. Some objects raised quiet alarms at once. One traveler in the outer halo moves at roughly 198 miles per second, where the escape speed is near 200. 2 miles per second from forever is a razor of a line, like a rocket held to Earth by the slightest tug. One nudge from never returning. So many on the threshold can't be chalked up to chance. Something placed them on that knife edge. Something gave them the energy to skim the rim without crossing it. One story is written in the slow collisions that built our home. When the Milky Way folded smaller galaxies into itself, the merging poured energy into the mix. Stars from the swallowed dwarf took velocity kicks. Some were flung free. Others settled into the fast, barely bound orbits we see now. The Sagittarius dwarf is mid-sentence in that tale. Its stars are being teased out as we speak, strewn in long streams and moving quick. Give them 1 billion years and they'll look like any other halo native, old, swift, indistinct, the signature of their birth washed soft by time. Another path threads through 3 body dances. When 2 stars drift past a third, gravity can turn mischievous. One star departs with a gift of speed. The others adjust, their energies shuffled like cards. In dense clusters, this happens often enough that the universe occasionally deals a star into the halo. Many of those ejected never look back. A few land just right fast, but not too fast, settling into orbits that flirt with escape and then do not. Black holes widen the possibilities. A close pass by a very heavy object delivers a slingshot no ordinary gravity can match. Lurking in our center is a supermassive black hole of some 4 million suns. Stars that stray too near are captured, consumed, or accelerated into true hypervelocity, some streaking away at over 400 miles per second. We've traced a handful of those trajectories back to the core, likely from binaries broken apart. One partner kept, the other hurled away. The barely bound stars are a different breed. They trace wide arcs in the halo, far from the black hole's immediate grasp, moving with high speed, but without the dramatic signatures of a central kick. They look as if they belong exactly where they are on the rim of leaving, but not quite. A stranger explanation leans into the darkness itself. What if the halo of dark matter isn't smooth but lumpy, with subtle concentrations at particular distances? In such a landscape, high-velocity lanes may exist, stable tracks where stars can move rapidly and remain bound, locked into a resonance with the unseen frame. It would explain why many edge runners share similar speeds. Testing this is delicate. We do not see dark matter. We infer it from the way things curve and cluster. If lumps are there, groups of quick stars should sometimes keep company, drifting in loose formations. A few surveys hint at such families. Others find more chaos than chorus. The data is a little noisy, the sky a little stubborn. Whatever the mechanism, the outer regions behave more wildly than the simple models promised. The boundary between staying and leaving is a hair's breadth, sometimes just a few miles per second between belonging and farewell. If our galaxy is larger than we once sketched, then more stars inhabit this precarious zone, more objects skimming the rim, more potential escapees, each one a probe of the halo's shape, each one a syllable in gravity's accent. Learning why they remain doesn't only solve a curiosity, it points to the deep architecture of the Milky Way, to how mass is layered, and how the unseen scaffolding guides what shines. Our spiral isn't a special case, not a neat exception to the universe's rules. If we read our own address wrong, we likely misread many others. That's the unsettling echo that keeps late-night coffee warm at observatory desks. If sizes everywhere run larger than the old numbers, the whole census shifts. Masses swell, gravitational reaches lengthen. In that wider picture, big galaxies strip stars from their companions with a firmer hand, reshape their neighborhoods with wider tides, gather satellites more easily, and build clusters with a different cadence than the models assumed. Change the masses, and the story of growth changes the rate at which galaxies merge. The eras when star formation surges or quiets, the balance between gentle accretion and dramatic feasts. Even our yardsticks feel the tug. Astronomers often lean on relations that tie a galaxy's brightness to its motion or size, using them as distance tools, the way sailors use lighthouses. If the typical sizes shift, the calibrations do too. Distances ripple outward. And because the grand question of cosmic expansion depends on those distances, because dark energy's strength is inferred from how far light has traveled, and how fast galaxies recede, errors at the level of luminous maps can seep quietly into the deepest equations. A small adjustment in the ruler becomes a long shadow across the room. So the sky is being reread. Old surveys, broad and brilliant projects like the Sloan Digital Sky Survey and the 2-micron All-Sky Survey are getting fresh looks with new techniques. Instead of drawing edges where starlight fades, astronomers are layering in the tug of stellar streams, the orbits of satellite galaxies, the subtle arcs of lensing. Piece by piece, a trend emerges that isn't easy to wave away. Many galaxies appear larger. Some grow by half again, others by a factor of 2. The pattern repeats across the local group. Andromeda widens. Triangulum stretches. The quiet companions bloom outward when you factor in the reach of their halos and the paths of their streams. If the nearby family turns out to be roomier, the far ones likely follow suit. Distant disks we counted as modest might actually carry halos that swell the map. The filaments of the cosmic web, those great strands, along which galaxies bead like dew, could be denser than the older catalogs showed. That would mean more dark matter than we'd penciled in, more weight to bend the paths of galaxies, more gravity to hum underneath the universe's expansion. Hold the image of those threshold stars while all this settles. Imagine them as sentinels, keeping watch where the Milky Way lets go of its luminous skin and continues as a field of quiet pull. They do not dazzle. They do not announce themselves. They move at impossible calm, fast enough to make numbers blink, slow enough to remain hours. And in their motion is a map, and in their speed is a question. How exactly does the unseen hold the seen? The answer will not arrive in a single thunderclap. It comes the way night comes to a field. First a dimming, then the brightening of the fainter stars, then the shapes you didn't know to look for. More data, more careful cross-checks, more patterns teased from motion and light. Perhaps lumpy halos will take a bow. Perhaps a past merger will be found guilty of the extra shove. Perhaps both, braided together, will explain why so many skaters glide the rim without falling off. Let the scale of it turn gentle in your chest, rather than heavy. The outer galaxy may be wild, but it is not lawless. Even there, the rules are patient. Even there, the dark frame is dependable. We live under that steadiness. We sleep inside it. And as you breathe in and breathe out slow, even picture those far-off stars circling on the edge, faithful to a gravity you cannot see, writing the shape of home in long, quiet strokes across a night that is larger than we knew. Ratios tilt quietly when no one is looking. The balance between what shines and what doesn't, the luminous matter we can name and the dark matter that refuses every spotlight, slides a little toward the unseen. That tilt isn't just bookkeeping. It threads through how galaxies are born, how they grow old, and how the whole universe finds its shape. When the invisible portion swells, theories of galaxy formation breathe differently. The scaffolding is thicker. The rooms built upon it can be wider. The timelines for assembling stars and spirals shift a shade earlier, as if dawn arrived before anyone set the clock. Old puzzles soften under this new light. There's the missing satellite problem, that long-standing mismatch between theory and sky. Simulations of a hefty galaxy surrounded by a deep halo predict not a handful, but hundreds of small companions in orbit, little dwarfs, dim as embers. We've counted only dozens. If the Milky Way's reach extends farther than the neat diagrams claimed, then the quiet suburbs where those satellites circle are simply farther out, dimmer still, their starlight sifted into the noise. Some are likely there, blushing at the edge of detectability. Every so often, a new ultra-faint dwarf emerges from the grain of the data, like a firefly found in tall grass, and the census ticks upward. Another knot loosens at the rim of the disk. Rotation curves those plots, showing how fast stars orbit as a function of distance refused for decades to behave like the tidy physics of our solar system. Far from the center, stars keep their speed instead of slowing, a flat line where a graceful fall was expected. Dark matter was the first corrective lens for that stubborn line. A larger halo pushes the correction farther, making the flatness feel less like defiance and more like a signature. Extending the mass out into the dark gives the outer stars something firm to lean on. The physics fits better. The night feels more coherent. Of course, rearranging the furniture in one room changes the draft in the whole house. A universe filled with bigger galaxies is a tighter neighborhood. The space between them shrinks. Tides grow stronger. Meetings happen sooner. Interactions that would have waited their turn now exchange glances across smaller gaps. Clusters, the big families, where dozens or hundreds of galaxies live together, begin to hum with a slightly different energy. Mass estimates shift. The orbits of members tangle more intricately, and the map of dark matter woven through a cluster needs recalibrating. The web tightens. The cords of gravity thicken. Look back far enough, and the news reaches the young universe as well. Distant galaxies are time machines. Their light left when the cosmos was fledgling and hot. If those far-off disks and blobs are larger than we measured, it means stars were assembling faster, structure was coalescing earlier, and the youthful universe carried more maturity than our models allowed. That touches everything. The ages we assign to stellar populations, the shapes we expect galaxies to wear at certain times, the growth rates of supermassive black holes that light up as active nuclei. Tug one thread, and the tapestry everywhere trembles. So the recount begins. Catalogues as grand as atlases, Sloan's vast survey, the 2-micron maps, whole libraries of images and spectra are being revisited with gentler tools and longer rulers. Edges are redrawn with the help of streams and satellites, lensing and motion. The picture that emerges is busier, denser, more layered. The Milky Way was simply the first domino to sway. Others follow in a soft, inevitable cascade. Andromeda widens in our new sight. Triangulum stretches. The bright knots along the filaments of the cosmic web sit upon larger, quieter pillows of mass than we first acknowledged. The universe hasn't changed. Our way of weighing it has grown calmer and more accurate. Amid all this redrawing, a subtler correction arrives close to home. Where, exactly, is center? Not the brightest knot, not the black hole's lair, but the balance point, the barycenter, the place where, if you could rest the whole galaxy on the tip of a pin, it would neither tip nor turn. It's a simple idea you already know. Earth and Moon circle a point, not at Earth's exact center, but a little off to the side, pulled by their shared gravity. Scale that notion up to our spiral. Add a halo of invisible mass that does not gather neatly at the core. Mix in a history of mergers that left clumps and seams, and the balance point wanders. For a long time, we placed it at the bright center because that felt true. Most of the stars we could count live there. The supermassive black hole anchors the nuclear region. The glow makes a compelling argument, but the dark matter doesn't vote with light. It spreads out in a sphere, lumpy here and smooth there, And when you include its full weight, especially in a galaxy wider than we thought, the midpoint slides. Not by thousands of light years, but by enough to matter. Hundreds, perhaps 1,000. In human terms, that's a gulf larger than the distance to our nearest star. In galactic terms, it's a gentle nudge, yet gravitationally honest. Why care about a center you cannot point to with a finger? Because motion listens to balance, not brightness. Stars trace their long ellipses around the true center of mass. Satellite galaxies, too, loop that point, not the place our eyes prefer. Even the orbit of our Sun around the galaxy, the 230 million-year circuit that carries us through one galactic year, leans on where that center really sits. Shift the pinprick we orbit by a fraction, and the period changes by a whisper. The path bends by a breath. Over eons, whispers add up. Measuring such a small slide demands a galaxy's worth of patience. You need velocities spread across the disk and the halo, distances measured to a fine thread, and models that include a halo's lopsided heft. Gaia provides the star-by-star heartbeat, a billion precise motions stitched into a coherent whirl. Feed that living map into simulations that allow the halo to be as uneven as the real universe, and the balance point steps, ever so slightly, away from the bright heart. Not a revolution, but a correction that ripples through every model that assumed perfect symmetry. Reality is never perfectly centered. The Milky Way is still settling from ancient meals. The Sagittarius dwarf is mid-fall, its torn mass tugging softly at our balance. Each encounter leaves a bruise in the halo, a small, off-center weight. Over millions of years, the barycenter may drift, oscillate a little, like a mobile, in a gentle draft. The galaxy breathes, inhales companions, exhales streams, and with each long breath, the balance shifts by a hair. Not chaos, just a dynamic center in a dynamic home. This invites a quiet question. If the true center of mass is offset from the supermassive black hole, what keeps the black hole where it is? These monsters are supposed to sit at the heart, gathering what the galaxy sends inward. The simplest answer is time. The black hole likely formed when the galaxy was younger and more symmetrical, when the balance point and the bright center were closer kin. As the Milky Way grew and the halo evolved, the mass distribution changed. The black hole, 4 million suns worth of stubborn, does not slosh around easily. It sits in the dense stellar hub like a stone in a river, while the broader current shifts. Over very long times, dynamical friction and fresh infall tend to recenter things. The drift may be temporary, a phase that smooths as the scars of mergers fade. Another answer is scale. An offset of hundreds of light years is profound to us, but modest to a galaxy. The central star cluster, gas dynamics, and the deep well carved by the black hole itself all conspire to keep it near the luminous heart. Meanwhile, the halo writes its own geometry in the outskirts. 2 coordinators, 2 centers, one for the bright bustle, one for the full weight, coexisting in a way that is less contradiction than complexity. With a moved center, models gain texture. Simulations that once assumed perfect symmetry learn to relax their shoulders, to let the halo be lumpy and the history be specific. Orbits of stars near the core tell a truer tale. Paths of satellites make slightly different loops. Predictions of how streams wrap the halo refine themselves by inches that matter on scales of tens of thousands of light years. The picture doesn't crumble. It acquires depth. Think of it like learning the balance point of your own body in the dark. Stand still, and you can feel the sway, tiny and constant, As your muscles make quiet corrections, the galaxy does the same. The dark frame isn't rigid iron. It's supple, responsive, a field that remembers every encounter and brands each memory into the way mass is arranged. The center moves because the story continues. Meanwhile, the ratios keep leaning toward the unseen. The census grows, and the cosmic web looks denser in the morning light. More satellites waiting in the outer hush. Flatter rotation curves that feel honest rather than rebellious. Clusters with deeper wells and more entangled orbits. High redshift galaxies that seem older sooner. Active nuclei flickering in timelines we're only now adjusting. Everywhere, the same note. Bigger halos, broader influence, gentler edges that fade instead of ending. Let that settle around you like a blanket. The universe isn't slipping out of our grasp. It's inviting a steadier hand. We weigh more carefully. We map more patiently. We learn that center is a conversation, not a dot. Somewhere in the mid-arm quiet of the Milky Way, your heart keeps time with an older rhythm, slow in, slower out, while a billion stars trace their arcs around a balance point that drifts by less than a breath. The models will keep improving, the ratios will keep adjusting, the dark frame will keep holding. What we called edges will stay soft, what we called certainties will learn to bend. And in that bending is comfort. A galaxy is not a finished object. It's weather that lasts billions of years. Storms of stars form and pass. Streams unwind. Centers migrate like the center of a flock, never a single bird. Always the shared motion. We live inside that flock, inside that halo, inside that patience. Close your eyes and feel the weight that does not shine, the balance that does not sit still, the cosmos that grows more intricate the more kindly we look. The Milky Way turns, not around a perfect point, but around a truth that moves quietly, gracefully, and somehow that feels exactly right. For now, in this still frame of a living galaxy, the balance point sits a little off-center. The Milky Way turns around a spot that isn't quite where our maps once placed it. Our home grew larger in our understanding, and with that growth, the center of everything, nudged small by cosmic standards, enormous by ours. We're only beginning to feel what that shift implies. The way a sleeper senses a subtle change in the mattress and adjusts without waking. Collisions between galaxies don't roar. There are no cinematic fireballs, no sudden wreckage, only a patient choreography. Gravity's slow ballet unfolding over hundreds of millions of years. Scale, though, changes the dance. The steps are governed by the same physics, but the performance differs when the dancers are giants. Small galaxies meet, sway, and settle in a few 100 million years, perhaps a billion. Massive ones, like our Milky Way and Andromeda, take their time, their deeper gravity weaving a more intricate, lingering pattern. It begins before anything bright touches anything else. Each galaxy wears an invisible cloak, a halo of dark matter that extends hundreds of thousands of light years. First contact happens when those halos overlap. Long before the starry disks draw near, the halos interpenetrate. Without colliding, dark matter passes through dark matter like mist through mist, yet the combined pull changes everything. Stars feel two centers at once. Orbits wobble. Paths that were steady begin to wander. The quiet edges grow restless. Then the outer stellar halos brush. The stars out there already move fast, barely tethered. With another heavyweight approaching, some are flicked outward into the deep gone to intergalactic space. Others are snared and kept by the oncoming galaxy, traded like tiny, luminous cards between two vast hands. As the bodies sweep past, tides rise. Gravity pulls harder on the near side than the far, stretching the disks and drawing long, gauzy streamers, tidal tails that can reach for millions of light years. They're beautiful in the way old scars are beautiful. Elegant, undeniable proof that something powerful happened here. Last to meet are the bright disks themselves. When they do, the gas clouds inside each are compressed. Compressed gas collapses. Collapsing gas makes stars. Across both galaxies, sparks kindle. A starburst, a sudden flowering of young suns strewn through the dust like fireworks seen in slow motion. This flaring doesn't last forever. It spends the reservoir. After the blaze, the cupboards of cold gas run low, and the lights of creation dim. Here is where size most asserts itself. A bigger galaxy holds more tightly. Material drawn into tidal tails has a way of arcing back in, recycled by the deeper well. Smaller galaxies lose more to the dark between. Larger ones keep more, weaving it back into their cores. The timeline stretches too. Small pairs might merge after 1 or 2 passes. Giants trace multiple loops, 3, 4, maybe 5 each pass, peeling off a little more, each turn drawing the hearts closer. Friction, not the kind you feel with your hands, but the collective tug of stars and gas, bleeds away orbital energy. The pair spirals inward. Eventually, the cores coalesce. When masses are comparable, the outcome is stark. The delicate design of spirals dissolves into a single massive elliptical galaxy. Disk stars are stirred, their orderly lanes rearranged into a warm randomness, like traffic seen from far above, moving in every direction at once. The nickname for our future child is Milkomeda. Picture a heavyweight with, on the order of hundreds of billions of stars and trillions of solar masses, the quiet ruler of a local neighborhood transformed. At the very center, another meeting waits. Each galaxy carries a supermassive black hole. After long pursuit, they, too, will pair and merge, releasing a low, deep chord of gravitational waves that would ripple across the universe. Star formation will surge with the first embraces, then wind down as the gas is used and heated. After a few billion years, the merged giant will glow with older stars, reddened by age, its days of exuberant star birth behind it, a calm ember in the dark. All of this is less prophecy than preview. The approach has likely already entered its first, invisible stage. The halos may be brushing now. If so, the collision isn't in our future tense, it's in our present continuous, unfolding on timescales too long for human nerves to notice. Scale points to the ending, the way the slope of a hill points water toward the sea. Bigger halos, deeper pulls, longer dances, grander finales. Yet amid the grandeur, there's a miscount that refuses to sit still. Add the light, you can see stars, gas, dust, and you tally something like a few 100 billion solar masses of ordinary matter. Weigh the galaxy by the way things move, and you read a total of trillions. Most of that difference is dark matter, the quiet heft that holds the structure together. Even so, another accounting problem remains. The missing baryons, the ordinary matter the cosmos says should be here based on its overall recipe, but which our inventories keep failing to find. The universe, on average, mixes a known fraction of normal matter with the dark. Simulations suggest a galaxy of our heft ought to contain a certain share of protons and neutrons embedded in stars, gas, and dust. our ledgers come up short. Roughly half the expected baryons are uncounted. Where did that matter go? One answer says, outward. Over billions of years, the galaxy breathes. Supernovae bloom and blow. Star-forming regions exhale fierce winds. Active galactic centers, when they flare, can launch material at near-escape speeds. Much of that gas doesn't vanish. It lingers far from the disk, thinned to invisibility. Another answer hides the baryons in forms that are hard for our instruments to love. Cold, diffuse clouds, dim brown dwarfs, rogue planets that keep to the dark. A third shifts the focus beyond galactic edges entirely. The intergalactic medium, an almost impossibly thin mist that nevertheless, across cosmic volumes, carries a surprising amount of mass. Perhaps many of the universe's missing baryons never fully settled into galaxies at all. Hints stack in favor of the outward breathing tail. X-ray eyes have seen halos of hot, ionized gas swathing galaxies, too energetic to collapse into stars and too tenuous to shine in ordinary light. These halos carry weight sometimes, enough to close much of the baryon gap. It's tempting to declare the case closed, but our revised Milky Way, heavier, broader, raises the target. A galaxy of trillions of solar masses should, by the cosmic ratio, carry hundreds of billions of solar masses in baryons. We can confidently count perhaps half of that in stars and cooler gas. The rest is still somewhere we cannot easily touch. Where to look? Far out, where the halo is more silence than song. The dark matter well can trap hot gas at immense distances, hundreds of thousands of light years from the bright disk, so thin and so warm that even our best X-ray instruments catch only a whisper. Future observatories with gentler ears may find vast reservoirs their mass hiding in plain sight. If plain means spectral lines we struggle to hear through the static, closer in lies a liminal region, the circumgalactic medium, where matter cycles between the galaxy and the great outside. Supernovae drive gas out. Gravity, cooling, and time draw it back. This two-way tide can store a great deal of ordinary matter in transit. It's neither fully inside nor truly outside. A weather system around the city rather than the city itself. New instruments, including infrared eyes sensitive to subtle warmth, are beginning to trace this flow, catching molecules and ions that other telescopes miss. Early hints suggest more mass than we'd logged, more structure in the outskirts than our first maps dared to draw. The work is delicate. The night asks for patience. Meanwhile, the shifted balance point continues its quiet drift. Models that once assumed a perfect, symmetric center are learning to live with a real one, offset by a few hundred light years, jostled gently by the memory of past meals and the pull of incoming companions. It's not a flaw, it's a fingerprint. The galaxy is not a statue, it's a dancer. Centers move in such worlds, not because the rules are broken, but because the rules allow stories. Hold the image together in your mind. Halos mingling before disks touch, stars traded at the edges, long ribbons unfurling, a starburst flaring and waning, black holes merging with a sound you can't hear, but the universe can feel. Accounts of matter that don't quite balance, missing mass stored as heat in a volume so thin your hand would pass through without sensation. A center that isn't quite where the light says it is, and a home whose edges fade rather than end. Breathe with it. Slow in, slower out. The future is immense and already on its way. The present is exact and gently incomplete. We live inside the correction, inside a galaxy that grew larger when we learned to look with steadier eyes. The dance has started, the counting goes on, and in the soft space between what we know and what we're still learning, the night stays kind, holding everything together with a gravity you cannot see and a patience you can feel. Here's the quiet discomfort. In the place we call home, we can't account for roughly half of the ordinary matter. We have a decent sketch of where the dark matter sits. That soft, invisible architecture is paradoxically the easy part. It's the familiar stuff: protons and neutrons, gas and dust, the bones of planets and people that keep slipping away from our senses. A larger Milky Way doesn't just widen the map, it deepens the mystery. The ledger grows by hundreds of billions of solar masses, and somewhere in that darkness, the missing light matter waits, uncounted and patient. Our spiral isn't an exception. Astronomy is full of lessons in humility. Whenever we think we're singular, the universe smiles and repeats the pattern elsewhere. If we underestimated our own galaxy, odds are we've done the same to others. So researchers turn their attention to our nearest kin, Andromeda, Triangulum, and a handful of close spirals close enough to weigh with care. They brought a new toolkit: the motions of satellite galaxies as clock hands, the arcs of stellar streams as gentle rulers, halo mass calculated from how space itself curves. One by one, the galaxies grew under this steadier gaze. Not a few percent more, like half again, sometimes double. The pattern lined up like stars in a winter sky. We've been measuring only the bright, missing the breath. Andromeda, the great neighbor hanging like a smudge to the north, stepped forward as a larger giant, its luminous span closer to 300,000 light-years than the tidy figure in old atlases, and its dark halo ballooning beyond that. Triangulum, smaller but lively, stretched from a modest 60,000 to something nearer 100,000 light-years. Lesser spirals followed suit, each extending a little farther into the dusk. The reason was ordinary and, in hindsight, obvious. We'd drawn boundaries where starlight became faint. We'd trusted the bright disk. We'd underweighted the halo. Modern eyes infrared that slips through dust, wide field surveys that hold the whole disk at once, deep exposures that catch the far rim pushed the edges outward. Then came the clincher: satellites and streams, the tiny companions orbiting each spiral, the long ribbons of stars torn from devoured dwarfs. All of them traced the true gravitational reach. The orbits weren't rumors, they were evidence. Every path said, bigger. When you honor the full halo, a spiral sphere of influence stretches by hundreds of thousands of light-years. The space between neighbors shrinks. Overlaps become common. This isn't just cartography, it's choreography. Overlapping halos mean galaxies tug sooner and more often. Encounters happen more frequently. Collisions begin earlier. The cosmic neighborhood grows busier, more conversational. Even the head count changes. If each galaxy occupies more volume, then any given patch of space contains fewer distinct galaxies than our older catalogs assumed. That echoes through cosmology. Cluster dynamics recalculated, mass budgets updated, timelines for structure formation nudged forward. There's a soft satisfaction here, too. Rotation curves the stubborn flat lines, showing outer stars moving faster than expected, fit more comfortably when a galaxy's mass extends farther out. The physics stops feeling argumentative and starts feeling coherent. The halo holds the rim returns the favor. Dwarf galaxies seem to sing the same tune. Early looks suggest their halos too. reach well beyond the visible sprinkling of stars. Ellipticals are trickier. No clear disks, softer edges, less to hang a ruler on. But even there, the first careful passes hint at larger sizes than tradition allowed. The problem is not local, it's universal. The bottom line is both simple and sweeping. For decades, we measured what glowed, drew lines where the glow grew thin, and mistook those lines for the truth. Across the board, spirals are larger than their portraits. The census needs a rewrite. The sky, it seems, is more generous than we were. When the map changes, so does the neighborhood. The local group, our cluster of bound galaxies, didn't physically compress, but our sense of its empty corridors did. We used to picture three great beacons, separated by long stretches of neutral dark. The Milky Way here, Andromeda there, Triangulum a little askew, dozens of dwarfs threading the space between. What the new measures suggest is less a trio on separate pedestals, and more three overlapping lanterns, their halos washing into one another. Our own dark aura likely extends a few 100,000 light years or more. Andromeda's does the same, perhaps more so. Subtract those reaches from the well-known 2.5 million light-years between our bright disks, and the truly neutral gap narrows to something closer to 2 million light-years, maybe less, if the halos breathe out farther. Some models whisper they may already be touching, beginning their long conversation in the only language gravity speaks. Blended boundaries change the rules of residence. A dwarf galaxy strolling between the giants can find itself tugged by both, a citizen claimed by overlapping jurisdictions. Orbits get tangled. Allegiances change with time. The Magellanic Clouds, those two bright companions in southern skies, once struck some as passers-by on escape trajectories. With a deeper well accounted for, the picture shifts. Our gravity's reach feels longer. The clouds look more like long-term residents, circling in the outskirts, destined eventually to be folded into the larger city. Between us and Andromeda, other dwarfs gather in regions where both halos murmur. Some will be kept by one, some adopted by the other, some shared for a while before a close pass hands them off. This is the part where the mind wants a clean answer, a new diagram with certain edges. The universe offers something better: texture. Galaxies don't end, they fade. Halos don't fence, they overlap. Territories are not declared. They're negotiated over billions of years by the soft arithmetic of mass and motion. That can feel unsettling from a desk built for tidy lines. In the night, it becomes almost comforting. The cosmos prefers gradients to walls. What belongs to what is a matter of how gently and how long things hold one another. Somewhere in those gradients lie the missing baryons, the ordinary matter our ledgers still can't fully find. A larger group means a larger expectation. More gas threaded through halos, more warm, thin plasma in the circumgalactic medium, more hot, faint atmosphere, suspended at distances where our best X-ray eyes squint. As instruments grow kinder to the subtle, we start to glimpse these reservoirs. The totals rise. The gap narrows. Not yet enough, not entirely, but closer. The Milky Way's bigger frame raises the target. The search lifts its chin to meet it. For now, let the revision settle like evening dew. Andromeda a little grander, Triangulum a little broader. The dwarfs farther out but still in the fold. The distances smaller where it matters. The local group hasn't lost its spaciousness. It has gained intimacy. The great lights have longer arms, and those arms are already brushing sleeves. Think of the map this way. 3 deep wells sunk into the same aquifer, drawing from overlapping waters. Between them, small springs dwarfs rise and fall, some pulled toward one well, some to another, some lingering in divides that shift like weather. The ground we thought lay flat between the giants proves to be gently sloped, and water matter flows along lines we're just beginning to trace. Breathe with that picture for a moment. The numbers carry weight, but they don't need to be sharp to be true. What matters is the sense. Larger homes, softer borders, nearer neighbors, and a dark scaffold more generous than we had allowed. We live in a group whose members already feel each other's pull, in a galaxy whose reach is longer than the glow implies, in a universe that keeps reminding us to count what cannot be seen. Somewhere beyond the bright disk, a dwarf circles in the shared twilight between our halo and Andromeda's, undecided and perfectly at home in the uncertainty. Somewhere closer, the clouds drift as loyal companions, not visitors, and all around, the missing light matter waits, part in the warm breath around the galaxy, part in distant, thin heat, part in forms we haven't yet learned to hear, while the dark frame holds steady and the stars, innumerable, keep their patient turning. Those little galaxies drifting between the giants live in a tug of war. Ask which home they belong to, and the honest answer is both, for a while. They move inside a shared field, feeling the pull from 2 directions, their paths braided by 2 deep wells of gravity. As our halo and Andromeda's lean closer, some of these dwarfs will be caught in the narrowing seam, stretched thin, unstitched into streams, quiet casualties of a conflict without anger, only inevitability. Triangulum faces a similar fate, third in size in this neighborhood, but only just on the order of 60 billion stars, and sitting closer to Andromeda than comfort suggests. The gap between them is roughly 750,000 light-years. With the wider halos tallied, their auras nearly touch. Triangulum begins to look less like an independent city and more like a bright suburb sliding into Andromeda's jurisdiction. As boundaries soften and get redrawn, labels change. A few objects we treated as standalone prove to be satellites. A few we tagged as companions show enough independence to stand on their own. The head count in the local group, about 80, doesn't shift much. The categories do. Even the balance point for the whole group slides. Weigh the galaxies with their fuller halos, and the shared center of mass settles somewhere between us and Andromeda, nudged toward Andromeda if it outweighs us by a shade. That point, invisible but real, is the bowl toward which everything rolls, the quiet fulcrum around which the local group turns. Beyond our neighborhood, the adjacent towns ask for new borders too. The Sculptor group, some 12 million light-years away. The Maffei group, closer but hidden behind our own disk's soot, each carries its own expanding aura. As their halos are acknowledged, the empty lanes between groups grow shorter. A few astronomers now sketch the local group as wider in reach than the old 10 million light-year definition, something more like 15 million across. Far-flung members we thought were strays still loop within the basin's lip. More of the nearby dark becomes part of our gravitational countryside. This trickles upward. Groups pour into superclusters, and those definitions, too, depend on where you choose to draw the line in a field with no fences. Whether we tuck ourselves inside the Virgo supercluster or gather into the larger weave some call Laniakea depends on those choices. Make the groups larger and the superclusters reorganize. The hierarchy shuffles at every rung of the ladder. Here's the useful strangeness. The borders are ours, not nature's. Matter doesn't stop at our chalk marks. Gravity smooths across space. Density fades by degrees, and galaxies overlap, mingle, and eventually merge. The local group is less a collection of separate objects and more a single basin with bright concentrations, cities in a landscape, rather than islands in a sea. You can redraw the map as much as you like. Reality keeps smudging the ink. Amid the redrawing, one number hums a deeper note. The star count doubled. Call it roughly 400 billion suns, and more hiding in the margins. It's a number that refuses to sit comfortably in the mind. Count one star per second, and you'd be reciting for more than 12,000 years. Still far from done. Earth holds about 8 billion of us. Picture 50 Earths, each fully populated, just to match the stars in this one galaxy. The old estimate ranked nearer 200 billion. The misstep came from how we sampled. We measured a neighborhood, extrapolated across a volume we thought we knew, and drew a line too close in. Double the radius, and volume doesn't just double, it swells by a factor of 8. Not all that extra space is rich with stars, but even sparse regions count. Add their faint contributions, and the total rises. The new additions hide in the quiet places. Red dwarfs, small, cool, common, make up the majority by number, around 7 in 10, and yet give off so little light that a billion of them can hide in plain sight. The outer reaches cradle more of them than we credited. Old surveys missed that whisper. New instruments tuned to softer notes pick them up. Farther out still, the halo holds more stars than our first ledgers allowed. Ancient, metal-poor wanderers from the galaxy's first chapters and immigrants from galaxies we absorbed. Every time we pulled a dwarf inside, we kept it stars. The Sagittarius dwarf alone has poured tens of millions into our outskirts. Its long stream, coiling around the disk, may hold 100 million by itself. All of those become part of our census, a multilingual crowd, born elsewhere and living here now. 400 billion stars also means 400 billion invitations to planets. Not every star hosts a family, but many do, perhaps most. If even 60% carry at least one world, that's something like 240 billion planets. Only a fraction will sit in the mild band where liquid water can linger on a rocky surface. Be conservative, 1 in 100, and you still have a few billion possible havens. Be harsher, 1 in a million worlds with life, and you still end up with thousands of living skies scattered across a single galaxy. Twice the number you'd guess from the older, smaller map. Aim the odds at intelligence so rare, it barely feels possible. 1 in a billion. And the arithmetic still leaves you with a couple of thinking neighbors in the dark, maybe more, whispering across the distances, or simply existing, unbothered by our lists. That logic runs through the Drake equation, the old, elegant chain of factors used to estimate how many civilizations can talk across the night. More stars, more planets, more shots on goal. None of it guarantees a voice at the other end, but each term leans a little toward maybe. The probability rises like a tide, which brings a familiar shiver. If there are hundreds of billions of stars and we've only sketched the nearest lanes with any confidence, what waits in the unlit corners of the ledger? The outer halo is a museum of oddities. Rogue planets drift with no sunrise. Failed stars, brown dwarfs glow in a slow, dim way that hides from easy surveys. Black holes, some quiet, some feeding, move like dark anchors. Neutron stars, tiny and fierce, roam on paths written by old explosions. There may be objects we don't have names for yet, things that ask us to build new words. And then there are the dwarfs between the giants, those hesitant citizens of overlapping realms. Whose are they? In the language of human maps, you have to choose. In the language of the cosmos, the answer is layered. They belong to the field itself, to the basin, to the gradient that runs from us to Andromeda and back again. As the two great halos press closer, some of those small galaxies will tatter into streams, others will be adopted. Triangulum, tucked nearer to Andromeda than to us, likely joins that family, if it hasn't already. The center of mass for the group hovers between the two big lights, a little closer to Andromeda, and everything dwarfs, debris, even the paths of hot, thin gas, responds to that quiet pivot. Farther out, where the local group hands off to its neighbors, the same story plays. The sculpted basins expand, the in-betweens narrow, the supercluster map rearranges. Membership becomes an answer with a footnote. We learn to accept that the universe doesn't honor our borders. It honors balance and motion and time. If the numbers blur a little as you listen, let them. The feeling is the important part. A neighborhood more intimate than our first sketches. A home richer in stars and worlds. A sky busier at the edges. The dwarfs caught between giants are not victims so much as witnesses to the way gravity writes history, sometimes gently, sometimes with a steady tearing that leaves bright ribbons in the dark. The doubled star count isn't just a statistic, it's a widening of possibility, a soft amplification of the question you've carried since childhood. Are we alone? Breathe with that question. Feel the room around you, the quiet of it, the warmth of it, and imagine, far beyond these walls, the long curve of two great halos brushing, the faint lanes where little galaxies drift, the uncounted red dwarfs pulsing in a darkness that isn't empty at all. Somewhere, in the shared twilight between homes, an old dwarf is being unstitched into starlight. Somewhere else, a planet circles a modest star in the outer disk, patient as a heartbeat. The map is larger than we believed, the census more generous, the borders softer. The night keeps its secrets, yes, but it also keeps its promises. Every star carries a quiet biography, a cradle in a collapsing cloud, a long, patient burning of hydrogen, an eventual fading into a white dwarf's ember, a neutron star's diamond-hard spin, or a black hole's velvet silence. 400 billion stories are unfolding at this very moment, scattered across our widened home like campfires on a continent at night. The sun is simply one more steady, middling, a single voice inside a chorus so vast it dissolves into hum. Not special, not chosen, just ours. A modest lamp in a city of lights. And that city just grew. The crowd thickened, which makes our loneliness feel stranger, like standing in a bustling station and hearing only your own footfall. So many stars, so many worlds, so many chances for a spark to catch, yet no clear signal has brushed our cheek. Still, a doubled count means doubled opportunity. More lanterns mean more windows. The search doesn't guarantee a friendly knock. It makes the street longer and the number of doorways greater. Begin with the quiet comfort of warmth and water. Around each star is a gentle band where a planet might keep liquid oceans close enough to feel heat, far enough to avoid the boil. That band shifts with the star's character, tight and intimate around red dwarfs, farther out around suns like ours, and wider still around giants. 400 billion stars imply 400 billion such bands, even before you ask whether worlds live within them. Kepler and her kin taught us a simple truth. Planets are common. Not rare jewels, but pebbles in a riverbed. If even a cautious share, say, a bit more than half host planets, then the count of solar systems swells into the hundreds of billions. Let only a modest fraction of those carry a world in the mild zone, and the tally of potentially temperate planets rises into the tens of billions. Habitable, of course, does not mean inhabited. A quiet ocean can remain empty for eons. Life needs chemistry, patience, and time without too much interruption. We have one good example, Earth, and a long history of humility about generalizing from one case. Perhaps life blooms whenever the conditions are steady. Perhaps it's so unlikely that our presence is a cosmic fluke. If you split the difference in your heart, letting life be rare but not impossible, one living world in 1,000 gentle orbits, you still arrive at a galaxy brimming with millions of small ecologies, each with its own weather and wonder. Most would be simple, microbial quilts, films of chemistry breathing slowly in ancient seas. Complexity takes longer, intelligence takes longer still. On Earth, for most of its history, the most intricate things were single cells. If thinking minds are scarce, 1 in a million living worlds, there are still dozens of civilizations spread across our spiral, perhaps a few score. Change the assumptions, and the numbers swing like a door in a night breeze. But the door now opens into a larger room, and there, in the larger room, the old paradox glows a little brighter. If opportunities multiply, why the silence? Why no steady beacon, no unmistakable artifact, no rendezvous at the edge of our system? Some imagine a filter, an unseen gantlet. Maybe it lies behind us, and life's first spark is the hardest part. Maybe it lies ahead, and self-made storms undo young civilizations before their voices carry far. Maybe intelligence flickers briefly on many worlds and goes out, a match in the wind. Or maybe we are simply early, or poorly placed, or listening with the wrong ears for the wrong kind of music. Yet the hopeful view has more room than before. Doubling the streetlights doubles the chance of a window left open. SETI keeps its vigil, sweeping radio and laser frequencies across the dark like a lighthouse mirror turning. Each survey covers a sliver of the whole, but the number of possible transmitters climbs with the star count. Meanwhile, new telescopes begin to read the breath of far-off skies. Webb has already started to sift starlight through exoplanet atmospheres, hunting for oxygen out of balance, for methane in the wrong company, for ozone and other markers that life, however humble, might write into air. Every confirmed gentle world, every hint of a biosignature, is another place to listen more closely. The odds don't promise, they invite. Stand with me at the imagined rim of the Milky Way and look outward, not for a fence, but for a fade. There is no cliff where galaxy ends and emptiness begins. There is a thinning of starlight, of gas, of the dark matter's hush. The boundary is not a border, it's a gradient. Think of Earth's air. Near the sea it's rich. Climb and it wanes, and keeps waning, farther than common sense expects, until a rare atom drifts thousands of miles above where your breath can no longer follow. Where does air end? We draw a line and call it useful. Nature shrugs and continues. So it is with our home. Near the center, stars crowd and cross like city lights seen through rain. Out by our address, neighbors are well spaced. The sky is generous with dark. Farther out, single stars can wander for 1,000 light years with no close companion. Beyond that, There are stretches where a cubic light-year holds nothing bright at all. Then, as if to make a point, a solitary ember appears a star on a long, lonely path, or a brown dwarf's faint glow, or the hidden tug of something that doesn't shine. Call those drifters, ours or not, depending on your purpose. The universe isn't offended either way. It isn't building walls. It's laying down gradients and letting time make decisions. Dark matter keeps the same counsel. Its density eases with distance. Its presence never quite reaches zero, within the reach of the halo. At some soft radius, we say, for this calculation, it's enough. Beyond this, we will call it between. Then a new instrument arrives, and the enough moves outward. That is not error, it is refinement. Maps were always less faithful at the edges. If this feels slippery, let it. The slipperiness is honest. We want crisp categories. The cosmos gives us fog that clarifies under better light. Our job is to improve the light and grow comfortable with the idea that borders are stories we tell for specific reasons, for building models, for making comparisons, for teaching. The underlying truth is gentler and more continuous. Return, then, to the beginning of this night's thought. Every star with a story, every story with its own pace. 400 billion of them, and the numbers swelling as our sight softens enough to see what was always there. Each story becomes a place where worlds might wander, and water might pool, and chemistry might lean toward life. Most will be quiet. A few will hum. A handful might think. Somewhere, in a town of red dwarfs at the edge of our disk, a small world turns through a long spring. Somewhere else, in the shared twilight between our halo and Andromeda's, a dwarf galaxy is being unwound into a ribbon of stars that will take 1 billion years to settle. Somewhere, a signal leaves a patient civilization and crosses 1,000 light years toward no one in particular. The way a message in a bottle drifts on a tide, content to travel. The map is larger. The numbers are kinder to hope. And still the night asks us to be patient, to listen longer, to widen our listening to include the quiet kinds of proof and atmosphere out of balance, a chemistry that can't be explained by geology alone, a faint flicker in a spectrum that means something is breathing. If contact never comes, we will still have learned more about our own garden. If it does, it will arrive in a moment like any other ordinary, earthly, and then not, and the edge we thought we knew will dissolve again, as edges do. For now, lie back into the knowledge that there is no hard border, only a dimming of lights and a lengthening of shadows, a slow drift from city to countryside to open land. Our loneliness is real, but so is company we haven't met. Breathe in, breathe out. Somewhere, many somewheres, 400 billion stories turn another page. And we, one small story among them, keep reading the sky. The halo reaches well past the places where starlight thins. How far is past? Our best maps whisper at least 250,000 light years. Perhaps 400,000, maybe 600,000, before the density slackens into the general hush of the cosmos. There isn't a cliff at the edge, only a long, soft slope. Dark matter is like weather you can't see, present everywhere, even across the spaces between galaxies. Its transition isn't a border, it's a gradient. Gas blurs the picture further. The Milky Way breathes. Supernovae bloom and push, and vast galactic winds carry material outward for hundreds of thousands of light years before it thins and quiets. Does that breath still belong to us? It was exhaled here. Much of it will cool and fall back in its own time. Yet for now, it glides beyond any neat line we care to draw. The Magellanic Stream is a perfect example. A ribbon about 600,000 light-years long, stripped from the Magellanic Clouds, no longer theirs, not yet ours, flowing through a twilight of between. Companions complicate the ledger, too. Satellite galaxies circle within our pull, with their own stars and architecture and history, separate and not separate at once. They are bound to us. Most will end as part of us. Are they the Milky Way? Yes, in one sense. Not yet, in another. To make sense of such messiness, astronomers lean on a practical shoreline, the virial radius, the distance within which gravity keeps the family moving together. For our home, that line falls around 250,000 light-years. It's tidy enough to use, never exact enough to be final. Beyond it, the Milky Way's pull fades, but does not vanish. The field stretches on, weaker and weaker, never truly ending. Light behaves the same way. Photons that left our stars centuries ago, millennia ago, aeons ago, are still moving, carrying the imprint of our spiral into distances where no map of ownership applies. In that gentle sense, our influence is infinite. Every star that ever shone here has sent a small announcement into the dark, which is why size is always a choice. Pick the virial radius and you'll get one answer. Choose a threshold for star density, or a fade level for dark matter, or the outermost orbits of loyal satellites, and the answer shifts. Not wrong, not right, just useful for a task. The universe is continuous. Matter and motion taper. They don't stop. What we call an edge is a story that helps us measure, not a wall the cosmos recognizes. And still, within this softness, the Milky Way is a hunter and a gardener of light. We grew by eating. Hundreds of small galaxies fell into our well, stretched thin, and were folded in. This is how large spirals become themselves, not just by steady rain, but by feasts. The evidence circles us like handwriting. Stellar streams loop the sky, each one the softened body of a dwarf that wandered too close. Stars drawn into long, translucent ribbons that will take billions of years to fully blur into the background. Sagittarius is mid-swallow now, a living lesson in how the work is done. It carries something like 400 million stars. In the next billion years, they will scatter across our disk and halo until the dwarf remains only as statistical ghosts, kinetic fingerprints, and chemical accents hiding in the data. Earlier meals were larger and left deeper marks. About 10 billion years ago, a substantial galaxy, Gaia Enceladus, arrived. Perhaps a quarter of the Milky Way's mass at the time. That was no nibble. The encounter was violent, in the slow way galaxies are violent. Orbits scrambled, star formation flared, and the loser disappeared into the winner. We know because its stars still move with an accent, many in retrograde, many on tilted, eccentric paths, and because their chemistry tells of a different kitchen, fewer heavy elements, distinct abundance patterns, a separate history folded into ours. Go back further and the footprints grow fainter. An older collision, nicknamed Kraken, may have struck around 11 billion years ago. Possibly half our mass then. It helped shape the disk we live in now, then mixed so thoroughly that only careful pattern finding can tease out its remains. There are smaller stories woven through Sequoia's distinct population, the Helmi streams, and Omega Centauri, a globular cluster so massive and peculiar it might be the stripped core of a once independent galaxy. Count the meals and you count the growth. 10 billion years ago, the Milky Way might have held something like 50 billion stars. a noble spiral, not yet a giant. Then came Kraken, then Gaia Enceladus. Then dozens and dozens of dwarfs, each adding its lights to our tally, each thickening the halo and deepening the well. The work continues. The Magellanic Clouds will drift inward on long paths and be digested. Sagittarius is already being unspooled. Other small companions circle too close to escape. One day, farther on than any calendar can hold, Andromeda will arrive, and the final meal will change our shape for good. None of this is cruel in the way human stories use the word. It is patient and inevitable. The slow metabolism of a universe that prefers to blend. Streams are memorials and seeds, both records of what was lost and raw material for what will be. Our halo is a graveyard and a nursery, a place where foreign stars learn our patterns and in time become simply stars. So we live with two truths at once, a galaxy that fades rather than ends, and a history written in long, bright scars. The first tells us measurement is a conversation with gradients. The second tells us identity is a conversation with time. If the edges feel uncertain, that's because they are. If the center feels restless, that's because it moves as the story continues. Breathe with that. The map will keep changing as our instruments grow kinder to the faint and the far. The Milky Way will keep changing as gravity rearranges what belongs to whom. And through it all, light leaves every star, crossing the dark in all directions, carrying the quiet news that we are here. Gravity has an appetite. Once a galaxy grows heavy enough, its reach lengthens like a tide, and the tide brings more driftwood. Catch a small companion, fold it in, grow heavier, reach farther, catch another. The cycle feeds on itself, quiet feedback, written in orbits rather than equations. For dwarfs, the night is less forgiving. They are the field mice of the cosmos, nimble but vulnerable, living under the long shadow of larger neighbors. Most are eventually gathered, unwound into streams, their lights added to a greater ledger. A few keep to remote pastures and survive. This is how our home came to rule its neighborhood, not by decree, but by dinner. And yet nothing truly vanishes in such a meal. The devoured galaxies still flicker, their stars still circle. They simply circle us now. The Milky Way isn't a single life. It's a consortium, a graveyard garden grown lush from dozens of small arrivals. The iron in your blood, the carbon in your breath, the calcium in your bones, much of it was forged in stars that died long before the sun. Some born in galaxies with names like Gaia, Enceladus, or Kraken. Their ashes drifted, mixed, and were folded into our cloud, our world, our bodies. We are made of travelers. The borders that once separated their skies from ours were erased by gravity, and we, without noticing, became citizens of a blended empire. The feast hasn't ended. Streams lace our halo. Dwarfs keep arriving. We are still adding other people's starlight to our own. Then came a new kind of candle to see by. The James Webb Space Telescope, tuned to the long reddened glow of dust-wrapped places, opened its eye and let us look where the night had been opaque. Infrared light passes through soot and smoke. Webb slips through the fog that stumped our older eyes. What it found in our own backyard was not a single revelation, but a steady drumbeat. More structure, more stars, more texture than our models had comfortably predicted. Regions we'd labeled empty turned out to be shy, not bare, populated by faint, scattered stars in numbers that add up when you count patiently. Webb traced the far side of the disk, peered toward the crowded heart, and resolved individual stars in dwarfs we once knew as smudges. Each precise distance, each chemical fingerprint, refined the map of our galaxy's pull. The refinements nudged the edge outward, and farther out still. The telescope followed the pale handwriting of stellar streams. Ribbons stretched 200,000, then 250,000 light-years from the center, too distant to exist if our galaxy were as small as the textbooks claimed. Their very presence wrote a larger outline. The heavier blow arrived from gravity's own ruler. Light from faraway galaxies bends when it passes near mass. The curve of that bend is a scale you can read. Webb's sensitivity lets those tiny deflections speak more clearly. Sum the bends, and you weigh the Milky Way. On the order of 4 trillion suns, the numbers said far beyond the tidy totals we'd carried. Other methods, independent and careful, tapped the same drum. Debate flared as it should. Old measures were defended, new ones argued, simulations adjusted, assumptions set aside. Gradually, the weight of evidence did what evidence is supposed to do. It shifted the room. The consensus moved. The correction stuck. Our home is bigger, heavier, and more complicated than we had allowed. The telescope's gaze didn't stop at our doorstep. It swung to Andromeda, to Triangulum, to spirals more distant, and to spirals almost unimaginably far. And the same pattern shimmered back, edges farther out, halos more generous, spheres of influence swelling beyond earlier lines. The error, it seemed, was not parochial. It was procedural. We had measured what glowed and underestimated what held it. This is the part of science that is both humbling and beautiful. Instruments grow kinder to the faint. Data contradicts comfortable stories. Models make room or make way. No one delights in revising a map they drew carefully by hand, but the alternative is to keep a wrong map on the wall and pretend the roads haven't changed. Webb didn't scold. It illuminated. And with the new light came new questions, as they always do. Some of those questions travel all the way to the edges of cosmology, where the universe's expansion is measured against its contents. To weigh the pressure that pushes space apart, what we call dark energy, you need an honest count of what pulls it back together: matter, luminous, and dark. If galaxies everywhere carry more mass, their gravity's hand is heavier. The expansion we measure through supernova beacons, through the stretching of light over time, hasn't budged. To reconcile a stronger inward pull with the same outward speed, you adjust the outward pressure. Perhaps dark energy is slightly stronger than we'd tallied. Perhaps it isn't the same everywhere or everywhen. Perhaps the gravity we use, which works so cleanly from apples to orbits, asks for a subtle amendment at the largest scales. There are ideas waiting in the wings. Gravity with a new term whispered into its law. Dark energy that ripples or evolves. A cosmos whose large-scale grain is not perfectly even. None of these proposals earns truth by being intriguing, but each becomes worth checking when the rulers lengthen and the sums change. Meanwhile, the universe's budget still reads, roughly, most of it is dark energy. A large share is dark matter. A smaller share is the ordinary material that makes stars and stories. The coincidence that their contributions are of similar orders today. A long-standing curiosity gets a new look when the mass side of the ledger grows. Through all this, the tone remains the same, patient, precise, and quiet as midnight. Our galaxy is not a fortress with a fixed wall. It's a weather pattern without sharp edges. It grew by folding others in, and we carry the evidence inside our atoms, We revised its size because a better lantern showed us more of what was always there. The correction cascades outward to neighbors, to clusters, to the very arithmetic of the universe's expansion, and inward, to the way we tell the story of home. If that feels dizzying, let it be gentle instead. Imagine the Milky Way as a city built over older cities, layers and neighborhoods blended. Street maps expand to include suburbs we hadn't noticed in the fog. Census takers realized they counted only the lit windows. The power company updates its load. City planners redraw districts, then redraw them again. Above it all, the same stars rise and set. The same river, gravity runs through the night, carving its banks in slow motion, widening one curve, narrowing another. And you, breathing in the quiet, carry pieces of many towns in your blood. You are the child of mergers, the heir of fireworks that happened before Earth learned the word for ocean. The telescope that changed our mind about distance also taught us a local lesson. We didn't know home as well as we thought we did. Now we do a little better. Tomorrow, better still. The sky is generous that way. Ratios in the dark should feel arbitrary, yet they rhyme. Most of the cosmos carried by dark energy, a large share by dark matter, a slim slice by the luminous stuff we know. Why these proportions, and not 90/10 or 50/50? The likeness has always felt like a wink. Stretch the galaxies larger, add more hidden mass to their halos, and the coincidence grows louder. To keep the universe expanding at the rate we observe, the outward push must answer the added pull. Either the balance has shifted with time, or the two dark ingredients share a deeper thread, different faces of one underlying thing. It's a clean thought, whispered in a messy room. Testing such whispers is hard. Dark energy doesn't clump or glow. It doesn't pool where you can point a telescope. We only meet it in the way distances and times dilate. Even our standard rulers in the sky, the faint ripples in galaxy clustering laid down as sound in the early universe, are tuned by how galaxies gather and how much mass they carry. If spirals everywhere are heavier and wider, the spacing of those ripples flexes by a breath. Calibrations shift. Distances tilt by a percent here, a percent there. Each tilt nudges our estimate of dark energy's strength. Closer to home, another riddle waits with its arms crossed, the Hubble tension. Nearby beacons supernovae set in a ladder of distance suggest one expansion rate. The afterglow of the Big Bang, read across the whole sky, suggests another. The two disagree more than our comfort allows. Heavier local galaxies complicate the nearby side of the ledger first, not the distant glow, so the numbers may slide toward each other or step farther apart. No verdict yet, only careful work and late-night coffee. It's worth remembering the calm center of all this. Our standard cosmological model is astonishingly good. It sketches the growth of structure across more than 13 billion years and gets the big strokes right. But it leans on free parameters, dark matter, dark energy values we measure without fully understanding. If the way we weighed galaxies was off, those parameters need retuning. The house doesn't fall, the floorboards creak. We still know the universe is speeding up. We're simply less certain why, and by exactly how much invisible pressure the acceleration is urged along. So we keep two kinds of knowledge in our hands at once, the firm and the provisional. Firm. The Milky Way is far larger than the tidy plate we once drew. Provisional. How large, exactly, depends on which honest ruler you choose. 200,000 light years across fits the evidence that speaks the clearest tonight. Push to 250,000 and you can still keep the streams and satellites happy. What's certain is that the old 100,000 figure is outgrown, folded neatly and set aside with a fond nod. Evidence has been generous. Stellar streams loop far into the dim. Satellites orbit on paths that require a deeper well. Maps of dark matter, drawn from the way background light bends, all point outward. Put these lines together, and the new outline holds reasonable, defensible, very likely close to the truth, not final. Final is not how astronomy works. What would make the outline crisper? A truer portrait of the halo shape, less guesswork in the dim outer miles, more direct weighing at the fringe. Gentle, wide field, lensing surveys that can hear the light's small deflections across huge swaths of sky. More tiny companions found in the outskirts, their orbits clocked until the family's mass sings a single note. Deeper counts of faint stars, especially the cool red dwarfs lost in the noise today. Clearer distances to the far-flung streams. Some lie at 150,000 light-years, some at 200,000, and a few sit so far out that parallax itself begins to fail. New techniques will help. We also need to follow the breath. Hot winds pipe out of the disk. How far do they wander before turning back? How much mass do they carry in the liminal region between galaxy and in between? That answer shapes where we draw a practical line, a shoreline that moves with the tide but still helps us navigate. Even familiar neighbors hold leverage. The Magellanic Clouds, our bright companions, are part of the equation. Pin down their orbits, and you pin down our mass. And between us and Andromeda lies the most delicate question of all. Where does one halo yield to the other? The first touch may already have happened in the dark. Defining that contact is how we date the opening step of a very long dance. New eyes are on the way. The Nancy Grace Roman Space Telescope will sweep vast fields deeply, catching shy satellites, tracing distant streams, and weighing mass with lensing across cosmic neighborhoods. On the ground, the extremely large telescope's huge mirror will pick out individual stars in remote companions and measure their motions with a jeweler's care. Each measurement tightens the threads. 200,000 light-years may tip to 220,000, or settle nearer 180,000, or expand toward 250,000. The uncertainty will shrink, the number will breathe, the truth will sharpen, and yet never calcify. All of which leads back to a simple, tender thought. We live inside our subject. We are trying to chart a city while standing in one of its side streets at night, listening more than seeing, mapping by footsteps and echo. Tonight's best answer is good and honest. Tomorrow's will be better. The galaxy continues to reveal itself, not in sudden trumpet blasts, but in a steady hush of corrections that add up. So hold the picture lightly. The Milky Way is larger than we believed, twice the width we taught, roughly triple the mass we carried in our heads, on the order of 400 billion stars and untold planets, a few billion temperate worlds, countless cold ones, and surprises we haven't learned the words for yet. It is a place of gradients rather than walls, of history written in streams, of centers that drift by a handful of light years as the past settles in. It is also, quietly, our home. The final figure? We don't have it. We may never have a number that refuses to budge, but we are close enough to feel the vastness, and closer every year. One measurement at a time, one stream traced a little farther, one faint companion added to the family. We learn how big the room really is and how gentle the night can be while we're learning. For now, call our spiral about 200,000 light-years across. Then exhale, and let the thought expand past the page, the way starlight does, without edge. So let that last thought exhale and grow quiet. Like a lantern set gently on water, the number drifts, edges soften, and the spiral loosens into night. Your breath settles with a dark, slow in, slower out until the room is only the hush between heartbeats, and starlight keeps traveling without an edge to choose. Maps can wait, questions can drowse. The long river of stars slides by like a tide at midnight, and your thoughts become faint constellations, then embers, then nothing at all. Let the final glimmer fade behind your eyes. Let the sky inside you widen, and if sleep finds you now, follow carried past every border we tried to draw.